Welcome to the Bare Metal Cyber CCISO Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Disaster recovery, or DR, is a vital component of a resilient cybersecurity and IT strategy. Its primary purpose is to ensure the timely restoration of critical systems and data following significant disruptions, whether caused by cyber attacks, hardware failures, natural disasters, or human error. While business continuity focuses on sustaining operations and communication across departments, disaster recovery zeroes in on restoring IT infrastructure and services. A strong DR program minimizes downtime, data loss, and operational chaos, ensuring that recovery processes are structured and achievable. DR is also essential for regulatory compliance and meeting contractual obligations. Organizations that fail to restore systems within promised timelines risk financial penalties, reputational damage, and long-term trust erosion. From a CISO's perspective, DR is not optional. It's a core security function that directly supports the organization's resilience and reliability. The CISO plays a central role in DR strategy and planning. While IT or infrastructure teams may lead execution, the CISO ensures that cybersecurity elements are embedded throughout. This includes validating that recovery processes account for firewalls, SIEMs, identity platforms, and other security tools essential for safe recovery. The CISO ensures that recovery objectives, particularly recovery time objectives, RTOs, and recovery point objectives, RPOs, are risk-informed and consistent with criticality levels established during business impact analysis. Collaboration with IT, business leaders, and infrastructure architects is essential for aligning recovery priorities with operational needs. The CISO also reports DR readiness to governance bodies, including gaps in recovery capabilities or security blind spots in backup systems. When done effectively, this oversight reinforces trust and supports executive decision-making during crisis planning and response. Every disaster recovery plan, DRP, must include a set of core components. The first is a complete and up-to-date system inventory that ranks systems by business criticality. This inventory identifies which systems must be restored first and the dependencies involved in that process. Recovery objectives must be clearly defined. The RTO establishes how long a system can be offline before causing unacceptable harm, while the RPO defines the maximum data loss acceptable based on the last successful backup. Backup and replication strategies form the backbone of any DR plan, whether that involves on-premise storage, off-site tapes, or cloud-based replication. Roles and responsibilities should be outlined clearly for DR execution and escalation. Finally, the plan must include schedules for testing and updates. A DR plan that isn't tested regularly cannot be trusted to perform when it is most needed. Before building recovery strategies, organizations must conduct a thorough IT impact and dependency analysis. This begins with identifying critical applications, databases, infrastructure components, and their interconnections. Mapping interdependencies is crucial. Restoring a database before restoring the application server it supports may create delays or additional failure points. The analysis must also account for potential failure scenarios, from physical hardware breakdowns to widespread ransomware events. Based on this analysis, the organization can determine the correct sequencing of recovery activities. This prioritization ensures that the most business-critical services are brought back online first, while lower priority services are handled later. Documenting these dependencies ensures clarity in the heat of an incident and helps drive alignment between business leaders and technical responders. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Backup and data protection strategies are essential to any DR approach. A robust backup plan defines how often data is backed up, how long it is retained, and how many versions are kept. These parameters should vary by system criticality and data sensitivity. Best practices include using immutable backups, meaning they cannot be modified or deleted by ransomware, and encrypting backup data both in transit and at rest. Backups should be geographically distributed, ensuring resilience against regional disasters. The CISO must ensure that backup coverage includes endpoints, servers, virtual machines, cloud workloads, and SaaS environments like Microsoft 365 or Google Workspace. Restoration testing is critical. Organizations must verify not only that backups exist, but that they can be restored accurately and quickly. Backups and their associated infrastructure must also be protected from compromise. If attackers can access or disable backups, the organization may have no path to recovery. Infrastructure recovery planning focuses on where and how systems will be restored. Hot, warm, and cold sites each offer different trade-offs. A hot site has near real-time replication and can be activated quickly, but is more expensive. A cold site is cost-feasible but may take days to restore. Organizations may also use cloud-based disaster recovery solutions, including DRaaS providers or IaaS replication to secondary regions. These options increase flexibility but require planning around connectivity, authentication, and security. Restoring access involves reestablishing secure connections, validating user credentials, and ensuring endpoint management. Image deployment strategies, such as pre-configured VM snapshots, accelerate system restoration. For hosted recovery options or managed services, contracts must define service-level agreements for uptime, recovery time, and support. The CISO must ensure these SLAs are understood, tested, and integrated into DR planning. Documentation is a cornerstone of disaster recovery readiness. Each system or service must have a step-by-step recovery procedure that reflects technical dependencies and current architecture. Roles must be assigned clearly, including who executes restoration steps and who communicates status updates. Communication protocols must be defined, especially if normal channels are unavailable. Plans must be stored in secure yet accessible locations, ideally off-site or cloud-based, to ensure availability even if the primary environment is down. Governance over documentation includes version control, regular review schedules, and ownership assignment. DR documentation should link directly to related plans, including business continuity, incident response, and cyber crisis management. This integration ensures alignment and prevents gaps or conflicts during real-time response efforts. Testing and validation are critical to confirm that DR plans will work when needed. Regular drills may take several forms. Tabletop exercises simulate the decision-making process. Failover testing involves transferring services to backup environments. Full functional tests validate end-to-end recovery. Key metrics include time to recover, accuracy of restored data, and system performance post-restoration. Testing must include not only business systems, but also security infrastructure. If identity services or SIEMs are not restored, monitoring and access control may be compromised. Cross-department coordination during tests ensures readiness across IT, security, legal, and business units. Testing results should be documented and used to refine recovery procedures. Every test should generate lessons that feed back into training, configuration, and recovery timelines. Despite its importance, DR planning faces multiple challenges. Recovery environments may be underfunded, outdated, or poorly maintained. Many organizations struggle to integrate cloud-native workloads, which require different recovery models than traditional infrastructure. Misalignment between disaster recovery, business continuity, and cybersecurity leads to gaps that are often revealed only during real incidents. Ransomware has changed the landscape by targeting backups themselves, making recovery impossible if protections fail. Over-reliance on untested processes or undocumented configurations also increases risk. These challenges must be addressed through sustained investment, executive support, and strategic oversight by the CISO. Success depends on preparation, not improvisation. On the CCO exam, disaster recovery is tested through terminology, scenario-based questions, and executive decision-making. Key terms such as RTO, RPO, replication, and hot site must be understood clearly. Candidates may be asked how to prioritize recovery activities, validate DR readiness, or assess plan gaps. The exam tests the CISO's strategic role in ensuring recovery aligns with enterprise risk, compliance, and resilience goals. DR also intersects with incident response. business continuity, and audit functions. Candidates must understand how to integrate DR into governance processes, track recovery metrics, and communicate recovery capabilities to executives and stakeholders. Mastery of disaster recovery strategy confirms readiness to lead during disruption and to build security programs that recover as well as they defend. Thanks for joining us for this episode of the Bare Metal Cyber CISO Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.